In this video, we're going to be learning about the t-distribution. So you should stop this video right now if in the Module 5 materials in the additional resources you have not yet watched the Crash Course Statistics video on test statistics. I think that video is really helpful for understanding what a t-distribution is. So if you haven't watched it yet, I would really encourage you to do that before you get started on working with the t-distribution in ALEKS. Okay, so in the dictionary, I want to take just a minute to kind of talk about why are we using a t-distribution. And you can see ALEKS gives you a very complicated description of what a t-distribution is. And so I kind of just want to simplify that for you. So what you've seen so far is that we're using the normal distribution or the standard normal distribution, and we've been dealing with letters like Z. Okay, and Z represents a normal distribution. But it's hardly ever the case that the data from a particular sample is a perfect or even standard normal distribution. Instead, what tends to happen is that we take a sample, it's usually pretty small, about 30 to 50 to maybe 100 people, and those data align to what we call a t-distribution. So the t-distribution is just like the normal distribution, except it's a little bit more spread out. The tails are a little bit thicker, and this is really just to express the uncertainty that we have in this sampling distribution. Okay, so I have this website that while you're here and I have your attention, I might as well talk to you about it. So this website from our psychologist is about understanding the t-distribution, and the idea is that if you increase your sample size enough, the t-distribution and the normal distribution are essentially the same. Okay, but as your sample sizes get smaller, the t-distribution kind of gets fatter, if you will, and gets farther away from the normal distribution. Okay, and so this is a little bit of a visualization website, and so we're going to be using the t-distribution when we don't know what the population variance or the population standard deviation is. So that's the main difference. If you're reading a problem and you have the population standard deviation, you're going to use the standard normal, you're going to do all the stuff we've already been doing in class. But most of the time we don't know the population standard deviation, we're estimating it from our sample, and that's when we want to use the t-distribution. Okay, so since we're estimating the variability in the population from our sample, we just have a greater level of uncertainty. We just don't know what's going on. The spread of the distribution is wider, it's bigger. Okay, and so we also refer to this as the degrees of freedom, and we'll talk more about degrees of freedom later, so I don't want to get into it a ton right now. But as the sample size increases, the degrees of freedom is always equal to the sample size minus 1. Okay, so what we can see here is that as we increase, so we have our t-distribution in this line and our normal distribution in the dotted line, and as we increase the degrees of freedom, which is basically saying as we increase our sample size, we can see that this solid line gets closer to the dotted line. Right, until, for all intents and purposes, by the time we've reached a sample size of 100, our t-distribution matches our standard distribution. Okay, so hopefully that's helpful to you. Okay, so let's get back to ALEKS and work on a couple of the problems here. So in this section of ALEKS, we're not doing anything with the t-distribution. We're just kind of seeing the shape of the t-distribution. Okay, so firstly, the problem asks us to consider a t-distribution with 18 degrees of freedom, and to find the probability that the t value is less than or equal to negative 1.55. Okay, so for this we're going to run into the same problem we ran into before, where the calculator does one thing, but we need a different value. So here, this is asking us for t less than negative 1.55, but the calculator in ALEKS only gives us p, the probability of t being greater than some number, and ALEKS represents this number as k. So again, since we want less than or equal to, we need to use the complement rule. And so we're going to be looking for 1 minus p of t greater than negative 1.55. And then we're just going to go to the ALEKS calculator. We have p of t greater than, so we'll click on there. And our number from this problem is negative 1.55. Okay, and then you'll see also in the calculator it asks for the degrees of freedom, and we have 18 degrees of freedom, so I'll just type that in there. Okay, and so p of t less than negative 1.55, we're not quite there yet, so remember this was for greater than, and so we need to do 1 minus this number, so 1 minus 0.9307. Okay, and so this is actually our answer, 0.0, and let's just check how many we round to at least 3 decimal places. So 0.070. Okay, and then the second part of the problem asks us to consider a t-distribution with 10 degrees of freedom, and we want to find a value of c such that the t-statistic falls between negative c and c, and that amount is 0.95. Okay, so this second part of the problem is asking us, well, so we have a little bit fatter of a distribution now, still sort of approximating normal, but we have some value negative c and c, that this shaded part under the curve is equal to 0.95. Okay, so according to this logic, that means that the area that we have over here to the right and the left of c and negative c, so this area here and this area here, okay, has to be equal to these two together. We'll call this A and B. This is not the notation ALEKS uses, but it makes it easier for me to think about. A plus B has to be equal to, remember the area under the whole curve is 1 minus 0.95. So A plus B is equal to 0.05. Okay, so these two together have to equal what's left, right? So 1 minus 0.95 is 0.05. And so we're looking for P where T is greater than or equal to C. And this is equal to the area that we have left. And then you have to divide it by 2 because it's to the left and to the right. Okay, so this is the probability of t greater than or equal to c being equal to 0.025. And then we know, okay, so I clearly did something wrong. This first time, I think I just used the calculator the wrong way. So we want t of 0.025 with 10 degrees of freedom. And I'm just going to double check that because I've done it 3 times now and I keep getting different answers. Okay, so that's the same answer at least twice, 2.228. Okay, did it right that time, so I must have just typed in something wrong. But you can see that these problems with the t-distribution are analogous to what you're doing or what you've already done in the standard normal distribution, except that the t-distribution and its shape depends on the sample size and because of that, the degrees of freedom, and so you have to take those into account when you're working on it.